Very well, thank you. So class, last week we have learned about biodiversity and now we are going to continue our new material. Anyone knows what we are going to learn today?
No, ma'am.
Okay. Um, who have ever gotten the flu?
Me?
Oh,
Me too.
oh, and Fitri and Iin? Have you ever got the flu?
Yes, ma'am.
Okay. Who knows what causes flu?
Virus, ma'am.
Yes, correct, Ali. Thank you. Today we are going to learn about virus. Virus is an ultramicroscopic infectious agent that are metabolically inert and which multiply only within the living cells of host. Virus, an infectious agent of small size and simple composition that can multiply only in living cells of animals, plants, or bacteria. The name is from a Latin word meaning simply liquid or poison. Let's continue what the characteristic of virus. Virus is different with bacteria. General characteristic of virus. 1. General characteristic of virus. First, virus are a cellular, non-cytoplasmic infectious agents. Second, they are smaller than bacteria, and this can pass through bacteriological filter. Third, viruses are transmissible from disease to healthy organism. Fourth, all viruses are obligate parasite and can multiply only within the living host cells. Fifth, virus contain only a single type of nucleic acid, either DNA or RNA. Sixth, viruses are host specific that they infect only a single species and definite cells of the host organism. And the last, viruses are effective in very small doses. They are highly resistant to chemists and extremes of physical condition. Do you got it, students?
I want to go to bedroom.
Oh yes, please. Okay, let's continue. Now I want tell about biological position of virus. Virus like sectomes. Now I wanna tell about biological position of virus. Virus like a cytoplasmic membrane and they do not have the basic component of a cell. They can only replicate inside the host cell. Outside the host cell, they are non-living. Those viruses show characteristics of both living and non-living. First, non-living characters of virus. Following characters of virus assign them as non-living. First, they can be crystallized. Second, outside the cell, they behave like innate semicolon. Third, they do not show growth, development, nutrition, reproduction, and etc. And the last, they can be precipitated. Now we are going to about living character of virus. The characteristic of living of virus is 1. They multiply within host cells. Second, they possess genetic material either DNA or RNA. And the third, there are definite records or strains. And the last, they exhibit mutation. Okay, we are continue about habitat of the virus. Please, Fitri, read the PowerPoint and share to your friends. Okay. Please read the habitat.
Viruses are not able to survive without a host cells,
So active virus reside inside a host body. They are present either in bacterial cell, animal cell, or plant cell. Example: herpes virus, TMV, bacteriopics.
Yes. Yes, thank you, Fitri. Then please, Iin, read the next slide and explain to your friends.
Of virus. Viruses are much smaller than bacteria. Viral size range from 20 up to 1,400 nanometers. Poliovirus is of 30 nanometers. Giant mimivirus are up to 800 nanometers.
Good, thank you, Iin.
Yes, ma'am.
Good pronunciation. And then we are going to learn about different shapes of virus. Please, Ali, read for your friends.
Different shape of virus. Virus are of different shapes. They are rod shaped, ballad shaped, flam shaped, icosahedron in shape, and tadpole shaped.
Thanks, ma'am.
Oh yeah, please sit down. Okay, let's continue our material. Now I will show to you the video about shape and shape virus. Let's watch the video.
When you're driving around on the road, you see all sorts of different types of vehicles. You've got SUVs, minivans, pickups, motorcycles, and 18-wheelers. In the end, they are all a type of vehicle regardless of their shape, size, and color. Likewise, viruses have many different shapes as well, and some of their shapes are unique to certain viruses and the things they infect. These shapes aren't just for looks. Like certain types of automobiles, they actually confer a function. Before we get to the nitty-gritty of this lesson, I'd like to point something out. The protective protein shell of each virus is called a capsid. This capsid is made up of protein subunits called capsomeres, which are in turn made of subunits called protomers. With that in mind, one type of car driving around in the viral world is known as a helical virus. This is a virus that has its capsid shaped into a filamentous or rod-shaped structure. This type of shape has a central cavity that encloses its nucleic acid. Some of these viruses are short, like a two-door car, while others are very long, like an 18-wheeler. Furthermore, many allow for a lot of flexibility or a lot of rigidity, depending on how the capsomeres are arranged. Another type of vehicle shape for transporting viral nucleic acids is called icosahedral. An icosahedral virus is a virus consisting of identical subunits that make up equilateral triangles that are in turn arranged in a symmetrical fashion. A special type of icosahedral shape, called a prolate, is a variant of the icosahedral viral shape and is found in bacteriophages. A lot of viruses are either helical or icosahedral in shape. Many animal viruses, which include those that infect humans, are icosahedral in shape. The icosahedral shape has been shown to be the most optimal way of forming a viral capsid for numerous reasons, but namely due to the fact that it provides the virus with a very stable shape with a lot of room inside for the storage of its passenger, the nucleic acid. In addition, because the protein subunits that make up the shape are identical, the virus doesn't have to waste a lot of its genome on encoding many different kinds of proteins for its capsid. This leads to conservation of energy and genetic economy. You can sort of liken this shape to the hybrid cars that have the highest fuel economy on the road and therefore save a lot of energy when driving about. Some people apply car wax to the outside of their car for an added layer of protection. Likewise, some viruses like to give themselves an additional layer as well. Although this additional layer is not so much for protection, but more for ease of infection. These viruses are called enveloped and are viruses that have a lipid bilayer around their protein capsid. This lipid bilayer is derived from the host cell's outer membrane or an internal membrane like the endoplasmic reticulum or the nuclear membrane. The viral membrane isn't just made up of fat, the lipids. It also has special proteins called glycoproteins coded for by the viral genome. The glycoproteins are really important in helping the virus infect another cell or host, and in helping the virus avoid detection by your immune system, which is trying to kill the virus. There are many different types of glycoproteins, and this type of specificity allows viruses to infect only the cells they need to. In addition, these glycoproteins can literally be shed by the viruses in order to throw the antibodies who are trying to kill them off course. Kind of like when military planes use flares to throw off heat-seeking missiles. In addition to adding a layer of wax to the car, some people like to really spice things up and add all sorts of add-ons to give their cars some kind of edge. This is no different with our viruses, as some of them have a complex shape. This is a virus that has a combination of shapes arranged in a symmetrical or asymmetrical fashion. For example, some viruses may have a prolate head with a long tail or even multiple tails. Well, now that it's the tail end of this lesson, let's simplify the main points. A helical virus is a virus that has a capsid shaped in a filamentous or rod-shaped structure that has a central cavity that encloses its nucleic acid. An icosahedral virus is a virus consisting of identical subunits that make up equilateral triangles that are in turn arranged in a symmetrical fashion. A special type of icosahedral shape, called a prolate, is a variant of the icosahedral viral shape and is found in bacteriophages. Some viruses, regardless of their protein capsid shape, are enveloped and are viruses that have a lipid bilayer around their capsid. Finally, some viruses have a complex shape. This is when a virus has a combination of shapes arranged in a symmetrical or asymmetrical fashion.
Okay. Is the video clear, students?
Yes, ma'am.
Good. Now we are moving with the last material, that is language material. So you should follow me. Repeat what I have told to you. Do you code it?
Yes.
Okay. We are going to learn about terminology and then Indonesian meaning. Let's start with word virus. Repeat.
Virus.
The meaning is virus. Virus.
Virus.
Indonesian meaning virus. Virus. And then microscopic.
Microscopic.
And Indonesian meaning microscopis. Host cell.
Host cell.
Indonesian meaning is cell inang. And then continue with nucleic acid.
Nucleic acid.
The meaning is asam nucleik. And then disease.
Disease.
Indonesian meaning is penyakit. And then resistant.
Resistant.
The meaning is tahan. And then question, okay? Are you ready?
Ready.
Okay, the first question is, please mention what are the characteristics of non-living virus? Ari, please.
I have no idea, ma'am.
Oh, yeah, okay. So, Iin, please help Ari.
They can be crystallized.
Yes, correct. And then, please Ali.
Be precipitated.
Yes, correct. Good. Okay, I think all is clear. So we can close our class. But before that, I will give you the assignment. Please write. Please write. Right. Please explain. Number one. Please explain what the general characteristics of virus. And the second, please mention living and non-living characteristics of virus. No. Okay, class. That's all for today. Thank you for your participation and happy next day.
Thank you, ma'am.
You're welcome.